right? Power equations. Okay, an equation, a power equation is an equation which can be written in the form of x to the n equals k, that n can equal 0. That's because if you had 1 to the 0 power, you would just get 1. If you had 2 to the 0 power, you would just have 1. 3 to the 0 power, you'd have 1, and so on. That's why n can't be 1. For example, if we have x to the third equals 5 or 2x to the fourth equals 20, those are power equations. In the first lesson we just did, we saw that x squared equals k has two real solutions where if k is greater than 0 and if there's no real solutions, if there's no real solutions if k is less than 0. This is in fact true for all power equations with even powers. So they're talking about if you had, x squared or x to the fourth or x to the sixth, you're always going to have, multiple solutions. You'll always tend to find ones that are positive and negative, that type of thing. If a power equation has an odd exponent, like x to the third, there will always be one real solution for n is greater than 0. We can write solutions in terms of the nth term root of k. So what they're trying to get at here is this is what we saw in the first lesson, and this is what we're going to focus on in the second lesson. When you have an odd exponent, you're not going to get plus and minus signs, is basically what's happening here. So if we look at our first problem, we have x to the third equals negative 27. Now to get rid of the exponent of 3, we would use the index. So the cube root, that means these are now opposites of each other and they can cancel out. So we would have x equals, and then you might ask, well, we have the cube root of negative 27. How do I figure that out? Well, go to your calculator. The first thing you're going to do is you're going to type in the number 3. Then you're going to hit the math button. Then you're going to scroll down to number 5. Then you're going to want to hit 5. You're going to see the symbol x with that next to it. And that's going to let you be able to type in whatever you want. So when you type that in, you're going to be able to get negative 3. So specifically negative 3. Okay, our second problem, we have x to the fourth plus 5 equals 15. We can minus the 5 over. So we have x to the fourth equals 10. And then we can go ahead and fourth root the problem. And we're going to fourth root both sides. So that means now the exponent of 4 and the fourth root, they're going to cancel out, leaving x equals. Now, since the index here is even, we're going to have the plus and minus fourth root of 10. If you have an even, exponent, or in this case, index, when we use the inverse, we'll end up with plus and minus sign. And you're done. You don't have to calculate what the fourth root of 10 is. It's some decimal. Okay, number 2. We have a problem similar to one we had in the last lesson. We have an exponent of 5, so we are going to do the fifth root. And these will then cancel out, leaving x minus 2 equals. This is an odd exponent, so I don't do the plus and minus sign. And then I'm going to go ahead and add the 2 over. So we are going to have x equals 2 plus the fifth root of 11. Our next one, we're going to do the third root, where we will have x plus 3 equals the cube root of negative 27 is negative 3. And then we can add, there we go. And then we can subtract 3 over. And so x will equal negative 6. All right, so for this one, we have x to the negative 5 equals negative 1 over 32. So this kind of goes back to something learned in the first 9 weeks about having negative exponents, which is equal to like 1 over like x to the first. So if I essentially want to make this exponent into a positive, what I can do is, since it equals negative 1 over 32, I can essentially switch the position. So it is negative 32 over 1, and that'd be x to the positive 5. Which means anything over 1 it's just really negative 32 here. And now I can solve it like the others, where I do the fifth root to both sides, and I will have x equals, the fifth root of 32 is negative 2. Once again, this just goes back to this old negative exponent property. So if we look at our second one, since we have x to the negative 4 equals 256, once again, going back to this property, if I want this x to the negative 4 to be positive, I can, once again, move its position. So instead of it being 256, it's 1 over 256, which means now I can go ahead and fourth root both sides, and I will have x equals, now this was even, remember, these are even, so we're going to get plus and minus, and then we're going to fourth root 256, 1 over 256. So once again, in your calculator, you're going to hit the number 4, then you're going to hit math, then you're going to hit number 5, because that's going to give you this little symbol, and then you can type in 1 over 256. That's going to give you a 1/4. All right, so now we're going to have equations in factored form, and we're going to solve them. So here is an example of a problem in factored form. This is going back to your Algebra 1 days using the zero product property, where if you have A times B is equal to 0, then you know that A equals 0 or B will have to equal 0. So we're doing the exact same thing here. Right here is a factor, so we're going to set that equal to 0, and then we have x minus 5, the other factor equal to 0. We solve each of these equations. So here we would divide by 3, so we would have x equals 0. Here we would add 5 to both sides, so x is equal to 5. Same thing's happening on the second one. Zero product property will let us set each one of these factors equal to 0, and then we solve the equations. So here we would add 4, so we would have x equals 4. Then we would minus the 7 here, getting 3x equals negative 7. Then we would go ahead and divide both sides by 3. So you have x equals negative 7 over 3.